154 or 6.1, we're supposed to do, I was asked to do 27, which was 9 degrees, 9 minutes, 9 seconds, and change it to degrees in decimal. So I have 9 degrees, and I have 9, see, minutes. There are 60 minutes in a degree, so 9/60ths of a degree plus 9 seconds, and there's 3,600 seconds in a degree, so I got 9 3,600ths of a degree. And so this works out to be, using my calculator, 9 plus 9 divided by 60 plus 9 divided by 3,600, and I get 9.1525 degrees. Next one. Change the radians to degrees. Well, for converting, you either multiply by 180 degrees divided by pi radians, those are the same size angles, or pi radians over 180 degrees. So these are equal in size. So this is an angle of 1, or ratio of 1. So I need to multiply this so that the radians cancel. Well, if I multiply by this, I'd get radians times radius. If I multiply this, I get radians over radians, and they would cancel. So I'm going to multiply by 180 over pi radians. And the radians cancel, as I said, 0 stays, so I got 0.75, or 3/4 of 180, which is 135. 0.75 times 180 divided by pi, and I get 42.9718 degrees. Close enough. Okay. Next one, it says arc length. Now I used arc length as length of the arc. They use S. The formula is the measure of the angle in radians times the radius. You tell me the radius is 6. The angle in radians is 2, so I have 2 times 6. So this is going to be 12 feet all the way around the circle, or for the angle of 2 radians. Now think about that. Has to make sense because 1 radian is laying the radius on the arc of the circle, 1 radius. So if I'm doing 2 radians, the length of the arc is a radius plus a radius. 2 radiuses, 12 feet, 6 feet twice 12 feet. Now it says the radius is 5. This is 5, but I'm only going 3 miles. The radius is 5 miles, but I'm only going 3. So I'm not going a full radius. So this is going to be less than 1 radian for the angle. So I'll just use the formula up here. The length of the arc is 3 miles equals the measure of the angle in radians, which I'm trying to find, so I'll write theta, times the radius. The radius is 5 miles. So if I divide by 5 miles on both sides, the miles cancel, the 5 miles cancel, and I get the angle is 3/5 radians. Okay, now they tell me the area of the sector. Well, the area of a sector is 1/2 the radius squared. That would be a whole half of a circle, and if I multiply by the radian, measure the pi r squared. No, 1/2 pi r squared times. No, I'm doing something wrong here. 1/2 arc length, which is pi, measure of the angle in radians, arc length times a half times the radius. Squared. No pi. 1/2 measure the angle times the radius. I had to think that one through. Sorry about that. So, the measure of the angle in radians is 1/3 times a half times the radius. Oh, we're supposed to find that. The radius squared equals the area, which is 2 square feet. So 1/2 times 1/3 is 1/6 r squared equals 2. Multiply both sides by 6 to get rid of the 1/6, and I get the radius squared is 12 square feet, and so the radius is the square root of 12, and the square root of square feet is just feet. Okay. And finally, the last one. It wants to know how fast the angle is changing. Well, it's going 1/3 radian in 20 seconds. So how many radians per second? So if I multiply by 1/20th, I get the angular speed to be 1/60th radian per second. So what's my linear speed? Let's see, that's angular speed, which is omega, and to get the linear speed, you take the radius times the angular speed. So I take 1/60th radians per second times the radius times 5 centimeters, and those reduce to 1/12 centimeter per second. That's the linear speed. And that's